Section 7.2, Systems of Linear Equations in 3 variables. So now we're going from 2 variables, just x and y, to 3 variables, x, y, and z. So now we have 3 variables in the problem. How do you solve for 3 variables? Well, it's honestly pretty complex. So what you have to do, well, it's actually not, it's a little messy, but not that bad. I'm being a little dramatic there. So step number 1, cancel, well, yeah, so I think that's true. Cancel one letter from any 2 equations. So cancel one letter from any 2 equations. That's the first step. Let's do that. So basically here's the deal. Let me put it to you this way. We have 3 equations with 3 letters right here. 3 equations that have 3 letters. We need to boil it down to be 2 equations with 2 letters. So we have to get rid of one of the letters. So how do we do that? Well, you can pick anything you want. Just do whatever seems easy. I'm looking at these y's right here. See how these guys are already the opposites, and I wouldn't need to multiply anything. If I just added those, those first 2 equations, call this equation 1 and equation 2. If I just add equation 1 and equation 2 right now, boom, those 2 will cancel. They'll cancel out, or I could call them equation A and equation B. Equation A and equation B. If you just add equation A and B right now, they'll cancel. So let's do that. So take equation A. So 5x plus 2y minus 4z is minus 11. And equation B is 10x minus 2y minus z is minus 19. If I add those up right now, do you see what's going to happen automatically? Those y's are going to cancel. You get 15x, and this will be minus 5z, right? Because minus 4z and minus 1z is minus 5. Add that up, I think that's minus 30. So we have a new equation. So there's step 1. Cancel one letter from any 2 equations. Step 2, cancel that same letter. Once you've decided what letter to cancel that same letter from any 2 other equations. So it can't be the same 2. It's got to be, you're going to reuse either A or B and then another one. What would be easiest would be A again, this time with C. Right? Cancel same letter from, well, let's see. Let's just put it this way. Cancel that same letter from the 3rd equation, or let's say the other equation. What other one you haven't used? Cancel that same letter from the other equation. So that'd be C. So let me write down here now A and B again. A and C this time. Equation A, I'm going to go back to equation A the way it was. 5x plus 2y minus 4z is minus 11, and equation C, which is minus 20x minus 2y minus 6z is minus 4. Add those up and see what happens right there. Boom, boom, the y's drop out. So we're canceling the same letter from the other equation. We're canceling y again, this time from the other equation, from the 3rd equation, C. So add these up. What is 5? 5 minus 20 is minus 15x. Minus 4z minus 6z is minus 10z. And this is minus 15. So now, see what I've got here? I've got 2 equations that just have x and z. No more y. I canceled y out. I started by canceling y, one letter from any two equations, and then I canceled that same letter from the other equation. So now I've got two equations with two letters. I can deal with that. So let me go to a fresh screen where I'm going to solve that. So I'm going to write that down. 15x minus 5z is minus 30. So number 1 here and 7.2. Oops. X minus 5z is minus 30. And the second one is minus 15x minus 10z is minus 15. Get that right? Yeah. So now that we have just two equations, you know what to do. We can add these right now. The x's are going to cancel. We don't even need to multiply here. This one's working out very conveniently. Minus 15z. They don't always work out this nicely is minus 45. So now we got x to cancel. So now we're down to one letter. We can solve for one letter. Divide by minus 15. Boom, boom. So z equals, that's going to be positive 3. And your calculator, two negatives make positive 3. So now we've got z. So we got one answer. Now we need to go back and get x and y. Now we're on to step 3. So step 1 was cancel one letter. Step 2 was cancel the same letter. We just did step 3 here, which is cancel another letter, or eliminate another letter, to get your first answer. So we got our first answer, we got z. Now, step 4, plug in your first answer back into step 3. Back into step 3 equation. So an equation from step 3. You see, we don't want to go all the way back to step 1 right now. We don't want to go all the way back here and plug in our z. Why? Because these equations back on step 1, they have 3 letters, x, y, and z. If I just plug in z, I'm still not going to know x or y. I don't want to do that. I want to just go back, say, to this equation, or the second one, it doesn't matter, where there's just x and z, plug in z, and I'll be able to find x. So I'll take that equation, 15x minus 5z is minus 30, and I'm going to plug in z right there. Z is 3. Right there. So now I can solve that equation for x. So add 15 to both sides. This cancels out. Minus 15, and then divide by the 15. Boom, x is negative 1. Now we've got x, we've got z, and now the final step, step 5, plug both answers into a step 1 equation. It doesn't matter which one, just grab one of the step 1 equations and you'll be good. So I'm going to go back to step 1, one of the originals. 5x plus 2y minus 4z is minus 11. So 5x plus 2y minus 4z is minus 11. I'm going to plug in x right there as negative 1. I'm going to plug in z right there as positive 3. So let's do it. Get rid of that x, get rid of that z. Plug in x is negative 1, plug in z is 3, and then work it out. What do we got? Minus 5 plus 2y minus 12 is minus 11. Kind of running out of room here. So I'm going to maybe squeeze up in here. If you combine this minus 5 and minus 12 is minus 17, right, is minus 11, add 17 to both sides. 2y is 6, divide by 2, y is 3. We got our three answers. X is negative 1, y is 3, z is 3. And those are the answers. X, y, z. So negative 1, 3, 3. That's how they want you to give the answer. Negative 1, comma 3, comma 3. Three numbers in parentheses with commas in between them. Let me write that a little better. Negative 1, 3, 3. There we go. That's how we solve three equations with three letters. So again, recapping. Step 1, cancel one letter from any two equations, like I got rid of y from the top two equations. Then cancel that same letter from the other equation. I got rid of y from the third equation. And then I had two equations with two letters. Once we had two equations with two letters, you know what to do. Cancel another letter. So we got our first answer, and then plug that first answer back into the equations that only had two letters. Get your second answer, then go back to step 1, plug in, get your third answer. Let's try another one. These are long. There's only 4 questions in this section because these are very long. Let's try number 2. So 6x minus 3y plus 2z is 13 minus 4x minus 6y minus 2z is minus 34. 5x minus 12y plus 2z is minus 17. Okay, step 1 is to cancel one letter from two equations. What looks easy to cancel here? What's going to be the easiest thing to cancel? Do you see it right here? The plus 2z and the minus 2z. They're already opposites, and then this guy's going to be opposite of the middle one. So that's what we'll do. So we have equation A, B, and C. So step 1, cancel z from A and B. So equation A, 6x minus 3y plus 2z is 13. Equation B, minus 4x minus 6y minus 2z is minus 34. Add them up and see what's going to happen. These guys cancel, so this will be 2x minus 9y. What's that going to be? Minus 21. So there's one equation with two letters. Now, that's step 1. Step 2, cancel that same z from the third equation. Equation C, right? We already canceled z from A and B. Now we have equation C left to go. So let's grab C. Now here's C. Here's the C. Now which one's going to, that's a plus 2z. That's the one we want to cancel. That same z from the third equation, from C, equation C. So want to cancel that plus 2z. Now what's going to cancel that out easily so we don't have to mess around with multiplying anything? This minus 2z. So this time I'm going to use equation B and C because it's already opposites. Now you could use equation A and you'd have to multiply through by negative 1 to make that negative 2z, so it would be the opposite of the plus 2z, but that'd be more work. Why mess with more work? Let's just do equations B and C, and that'll take care of it for us. So here we go. So equation B, minus 4x minus 6y minus 2z is minus 34, right? B is a true equation. The two sides are equal, so if I add it now to the next equation, equation C, if I add these together, then they have to be equal results also. So the z's cancel. So this is 1x minus 18y, and this is minus, what's that, 51. All right, so there we go. See how I have this equation here and this equation here. Two equations that only have two letters. They just have x and y. I've eliminated z from all the equations. Now I have two equations with two letters. We know what to do now. So let's bring that over to step 3. So 2x minus 9y is minus 21. Minus 9y is minus 21. And 1x minus 18y is minus 51. Okay, so this is now step 3. Eliminate or cancel. Eliminate another letter. So we're going to eliminate another letter. So now this time we can't just add them, right? Do you see the problem? If I just straight add, don't write this down, I'm going to get 3x minus whatever that is, 27y equals minus 72. Nothing cancels out. Nothing eliminates. X is still there, y is still there. That's no good. Remember, you got to make them opposites first. So what could I do? Well, you could multiply. You can make the x's or the y's. I'll just make the x's opposites. It doesn't really matter which one you do. I'll do the x's. I'll multiply through this by negative 2. See how that'll work? Negative 2 times that will make that negative 2x, which is the opposite of positive 2x. The negative 2's got to multiply all these, though. So what are we going to get? I'll bring down the top equation, no change. 2x minus 9y is minus 21. But the bottom equation will become minus 2x as that negative 2 distributes through, plus, what is it, 36y? Right? And the negative 2 times negative 51 is positive 102. There we go. Add these up. These x's cancel. And this is 27y. And this is 81, I believe. Yeah, 81. Okay. So we're getting close on this one. Now we can finish solving for y. Down to one letter. Divide by 27. Y equals 3. We got our hands on y. So we got our first answer. In fact, let me write it over here. Y is 3. Okay, so now, what do? Now we go to step 4. Done with step 3. Step 4, we're going to start plugging stuff in. But remember, we don't go all the way back to step 1 right now. Not yet. We only have one answer. So we just want to go back right here to where we just had 2 letters. Plug into an equation from step 3. All right, plug into that one or the second one. It doesn't really matter. So I'm going to take that equation, which is 2x minus 9y is minus 21, and I'm going to plug in that y right there to be 3. And so what do we get? 2x minus 27 is minus 21. Add 27. 2x equals, what's that, 6. Bring it over here. 2x is 6. And then divide by 2. X is 3. So we got our second answer. We got two answers. So now you know what, now we go all the way back to step one. Plug in our y is 3, our x is also 3, and we'll get our third answer. Let's go there. So step 5. Plug both answers into step 1 equation. In any equation from step 1, doesn't matter which one. So from step 1, I'll just grab the very first one. 6x minus 3y plus 2z is 13. And I'm going to plug in, what two answers did we get? Y and x are both 3. So I'm going to plug in x is 3 right there, and y is 3 right there. So I get 6 times 3 minus 3 times 3. And now we can solve for z. 18 minus 9 plus 2z is 13. What's that? 9. 18 minus 9 is 9. Right? And then subtract the 9 from both sides. Z is 4. Last step, divide by 2. Z is 2. So we got all of our answers. X, Y, Z. X and Y are both 3. Z is 2. There we go. Let's go to number 3. Now we're going to word problems. These are word problems. Number 3 and number 4 are word problems that will lead to 3 equations with 3 letters. Here we go. A movie theater has a seating capacity of 345 people. That's how many can stay in the theater. It charges $5 for children, $7 for students, $12 for adults. So there are half as many adults as there are children. If the total ticket sales was $25.04, I'll put the dollar sign over here next to it. How many children, students, and adults attended? Let's call it children, students, adults. Well, let's just go X, Y, Z. I think that's going to get confusing. X, Y, Z. All right. Well, I keep changing my mind. How about children, students, adults? Okay. So what does it say? Seating capacity 345. So now with 3 letters, you know we need 3 equations. If you've got 2 letters, you need 2 equations. If you've got 3 letters, you need 3 equations. So the number of children plus the number of students, my S's can look like 5, so we got to write careful here, plus the number of adults is 345. That's the total number of people that can sit in the thing. That's the seating capacity. And I guess I'm assuming they filled it up. They never said that. They should have said that. They should have said the movie theater was packed to capacity, right? And because otherwise, how can we figure out this problem? We're assuming that, so they should have said that really. So next, so that's just people. That's just total people filling up the theater. Next, we're going to do the money, right? It's $5 for each child. So however many children showed up times $5 each. $7 for each student. However many students showed up times $7 each. And it's $12 for each adult. However many adults showed up times $12 each. That has to add up to the total ticket sales, $25.04. That's all the money they gathered. Now, 2 equations right now. I need 1 more equation, right? When you have 3 letters, you need 3 equations. What other fact do they speak of that I haven't done anything with yet? Right here, right? Half as many adults as children. Now that could be a little tricky. There's half as many adults as there are children. So in other words, the number of adults is half the number of children. The adult number is half the child number. like that. There we go. Okay, now that's a funny third equation, isn't it? So adults equal half children. So we have a people equation, a money equation, and adults is half children equation. Okay, so now how are we going to solve 3 equations in 3 letters? Well, what should we do? Well, do you know what we could do? I'm going to do kind of a substitution. You know the general game plan when you have 3 equations with 3 letters is you got to boil it down to be 2 equations with 2 letters, right? You got to get rid of one of the letters. Well, what we could do is take this half C, because A equals half C, and plug it in for A right there, and plug it in for A right there. And then there wouldn't be an A anymore. Let's see what we get. So that would give us C plus S, plus then when we come to A here, it's going to be a half C equals 345. And then that's the first equation. And then the second equation. Second equation is 5C plus 7S plus 12 times A, but what is A? A half C. Makes sense. I plugged a half C in there for A. Equals 2504. Now, can we clean those equations up a little bit? Well, yeah, we could. Let's see, the first equation, C plus S plus a half C is 345. The second one, 5C plus 7S. What is 12? What's half of 12? Half of 12 is 6, right? See what I did there? Half of 12 is 6. Okay, this is an S. Remember, my S's can look like 5s. Got to be careful here. So, okay. So now, we don't really want a fraction in here. Fractions are kind of a pain. See how we have this half here? We don't want a fraction in the middle of our thing. So let me see what should we do with that? We could just make it a decimal. Yeah, we could do that. We can let's just make it a decimal. All right? So it's half is 0.5, right? It's just 0.5C. Okay. And now let's combine those together. 1C and 0.5C is 1.5C plus S equals 345. So there's the top equation. Now the bottom one I'm going to combine. So I combine the 1C and the 0.5C to get the 1.5. The bottom 5C and 6C is 11C plus 7S is 2504. Now I've got 2 nice equations with 2 letters. I've cleaned them up and combined them. So you see what I did? By plugging this A into the 2 equations, I got rid of A. And so now I have 2 equations that have 2 letters. I know how to solve that. Let's go to a fresh screen where we have room. So I'm going to write these 2 down. 1.5C plus S. 1.5C plus S is 345. This is an S. I'll make sure my S's look good. And then back here, second one is 11C plus 7S. 11C plus 7S is 2504, I believe was the number. All right, so now, and this is problem number 3 here we're still working on. So now, how do we finish solving this thing? We got to get rid of something, right? You want to multiply to cancel out. I don't really want to deal with that decimal. That looks weird. I'm going to deal with that 1s. I'm going to cancel out the s's. Looks kind of weird. S's. So I'm going to multiply this top equation by -7. See how that'll work? Boom, boom, boom. -7 times 1s will make -7s. That'll be the opposite of the positive 7s. That'll work. So now use your calculator. -7 times 1.5. I think that's 10.5. Make sure I'm right here. 10.5, right? Minus 10.5 minus 7s, and then 7 times 345, or minus 7 times 345, minus 7 times 345 is minus 2415. So there's the top equation. The bottom equation, no changes. 11c plus 7s is 2504. Add them up. So now, multiply to cancel out s's. Add, so that's step 1. Step 2, add to eliminate. It's called the addition method or elimination. So these are going to eliminate because we made them opposites. Multiply to, well, I should have said multiply to make the s's opposites. That's what I really did on step 1 there. I multiplied to make them the opposites, and then I added them to eliminate. So what do we got here? 11c minus 10.5. $11 minus 10.50 is 0.5c, isn't it? And that equals, I don't know, what's that? I'm going to subtract it on my calculator here. 2504 minus 2415, 89. Last step, divide by 0.5. Last step to solve for c anyway. So I'll just write it over here. C equals 178. So there's C. 178 children must have attended that movie. Now we have to find the other two, the adults and the students. Let's go back, see what we can see. We want to plug in somewhere where we just have 2 letters. What do we got? What would be easy actually would be to grab this equation right here. Adults is half of children, right there. Let's just use that. We can use any. Could we plug into these two? Yeah, we could. But look, adults is half children. That's even easier. You can use anything you want. So I'm going to use adults is half children. Plug in 178 there. Adults is half of 178. So divide by 2, in other words, 89. So A, the number of adults that went to the movie must have been 89. Now we can, what do we got left? We got children, we got adults, we got to find students. Now I'm going to grab like this equation. Well, you can go back to the very first equation. You can go to anything really, anything you want to at this point. I'm going to grab the first equation. Children plus students plus adults, 345. So children plus students plus adults, 345. Plug in the children right there, 178. The adults right there, 89. So 178 plus students plus adults, 89, 345. And then add 178 and 89. I don't know. What's that? 267. So students plus 267 is 345. Bring it right here. Students plus 267 is 345. Subtract 267. And we've got it. Students equal 78. Must have been 78 students. And there it is. We figured out how many of each type, children, students, and adults, were at that movie. So that one's pretty tricky. A little bit of work there. 3 equations, 3 letters. Let's go to number 4, our last problem. Maricopa's Success Scholarship Fund receives a gift of, what is that, $105,000. The money is invested in stocks, bonds, and CDs. CDs pay 3.75%, bonds 2.6%, stocks 7.9%. Maricopa invests 10,000 more in bonds than in CDs. If the annual income from the investments is 49,000 or 4,930, how much is invested in each kind? So we'll say stocks, bonds, CDs. I think it's easier than using XYZ. All right, so 3 letters, you know what that means. We need 3 equations. So let's get our 3 equations. So the first one is the total money. It's the gift of 105,000. So total dollars. Total dollars. So that's the stock money plus the bond money plus the CD money must be $105,000. The second one is going to be about the interest. So that's going to be the interest percent. So the interest. So what does it say? The stocks. Whereas the stocks pay 7.9%. So change that to a decimal. 0.079s. The bonds pay 2.6, so change that to move the decimal back 2 places there, 0.026b. And the CDs pay 3.75%, move that back 2 places, 0.0375c. And that total interest, the total income from those investments, total interest is 49.30. That's the interest income. That's the income they get from those investments every year, annual income every year. Finally, 3 equations. Well, for 3 letters, we need 3 equations. So we need a third equation, as you know. What other fact do they speak of that we have not used yet? It's right here, huh? It invests 10,000 more in bonds than CDs. So the bond amount is 10,000 more than the CD amount, right? 10,000 more. The bond amount is 10,000 added to the CD amount. So there we go. There's our third equation. Now we can start solving them. We have 3 equations with 3 letters. So how do we go about solving them? Well, we're going to do just what we did in the last one. We're going to take that B, that third equation, and plug it in for B there and plug it in for B there. So let's do that. So what do we get then? This is going to be, bring down that first equation. S plus, but when we come to B, instead we'll plug in 10,000 plus C. Plus C equals 105,000. And then the second equation, bring it down here, 0.079s plus this guy, 0.026 times B. And what's B? 10,000 plus C. Plus, and then 0.0375. C is 49.30. See how now we have 2 equations that only have 2 letters? Be a little bit easier. Right? There's just S and C. No more B. So let's bring down the first equation again. S plus 10,000 plus C plus C. So S plus 10,000 plus 2C, right? 1C and 1C is 2C, is 105,000. The second equation is 0.079S plus, and then this distributes 0.026 times 10,000. Use your calculator, it will be 260 plus 0.026C plus 0.036 7.5c is 4930. So we need to combine terms. We're out of room. I need to go to a fresh screen there. So S plus 10,000 plus 2C. Let's do that. This is number 4. Oops. I think I forgot what was there. Let's go back. What is it? S plus 10,000 plus 2C is 105,000. So there's that first equation. S plus 10,000 plus 2C is 105,000. Second one is 0.079S plus 260. Okay, so here it all is rewritten. Now let's combine terms. So take that top equation, and I'm going to subtract 10,000 from both sides because we want to get the letters on the left and the numbers on the right. So that'll give us S plus 2C, and on the right, that'll give 95,000. So we got the first equation cleaned up nicely. The second equation, what are we going to do here? I'm going to combine these two. So it'll be 0.079S. Oh, and I'm going to subtract the 260 also. Subtract 260, subtract 260. So that's gone. Plus, and then 0.026 and 0.0375C, use your calculator. I'm getting 0.0635C equals, and then these subtract over here, 4930 minus 260, 4670. Okay, and then now we have two equations with two letters after a lot of cleanup work. Two equations with two letters. So what are we going to do here? Well, this is a mess, isn't it? We want to make. Why don't we do the plug-in? I don't want to. Yeah, I'm just going to do plug-in. So I'm gonna get S alone in the top equation. Plug into the bottom equation. So I'm going to take that top equation and I'm going to get S alone. So I'm going to jump this 2C to the other side. Remember, when things jump to the other side, I'm just subtracting 2C from both sides. So it'll be 95,000 minus 2C. And then I'm going to plug that into the bottom equation. Let me bring down the bottom. 0.079S plus 0.0635C is 4670. So I'm going to take that right there and plug in for S right there. So then what do we get? 0.079 times S, and what is S? 95,000 minus 2C plus 0.0635C is 4670. Okay, we're down to one letter. This is a long problem. So now let's distribute. Use your calculator. 0.079 times 95,000. I'm getting 7505 minus 0.079 times 2 is 0.158C plus 0.0635C is 4670. Combine these two together. 7505. What's that going to be? It's going to be negative 0.0945C is 4670. So we're close to getting C. We're still not done. This is a long problem. Let's go to another page. Okay, here we are on the next page. Let's solve for C. Subtract 7505 from both sides. And we get minus 0.0945C is 4670 minus 7505. We get a minus 2835. Last step is divide by minus 0.0945 minus 0.0945. And we got a really nice clean answer, 30,000. That came out really nice. After all that mess, two negatives made a positive, 30,000. So we got an answer for C, the amount they invested in CDs. So we got our first answer after all that hard work. Now we got to go back. Now the easiest place to go back would be an equation involving just C and one other letter. You could go to a lot of places, but I think the easiest place would be back here where we had this equation right there. See this one right here? B equals 10,000 plus C. Choose that one. Bonds is 10,000 more than CDs, right? So bonds is 10,000 plus CD. CD plug in 30,000. So bonds must be $40,000. Must have been invested in bonds. Finally, we just need stocks now. What can we do for that? We can plug into the very first equation if we want that said stocks. That's an S there. Stocks plus bonds plus CDs is the 105,000, that very first equation. So if you plug in 30,000 there and 40,000 there, you get S plus 40,000 plus the 30,000 equals the 105. You add those up. What's that? 70,000. That's a 7 there. And last step to finish solving for S. Subtract 70,000. Boom. S is 35,000 must have been invested in stocks. And so we solved the whole thing. That was quite a challenging problem. There we go.